Okay, so number 19, complex numbers, part 2. Complex numbers continued. It's more complex numbers. Whatever you want to call it. It's just the second day of complex numbers. Again, mostly it's division and a little bit of simplifying, but we're going to also go back and make sure we review the multiplication because that's going to lead us right into the division part of what we got to do today. All right, so let's backtrack to, again, what we were doing yesterday. All right, so let's go back to a full method problem like we were doing yesterday where we had to multiply, just to kind of refresh everybody's memory real quick. All right, so go ahead and set up your full method. You got 2 times 2 and then 2 times negative 3i. So 2 times 2 is not 2. How about 4? 2 times negative 3i is negative 6i. And then when we go underneath, 3i times 2 is 6i. And then 3i times negative 3i is negative. And again, when you do I times I, it is I squared. All right, so 2 big things are going to happen. You got your middle terms here. What happens when you do 6 minus 6? It's 0, right? So you get 0i, which is just 0, which basically means that part's out and gone. We're going to take the I squared, replace it with negative 1. So that's negative 9 times negative 1. That's a positive 9. So it's 4 plus 0, which doesn't do anything, plus 9. So in that case, the answer is out to be 13. All right, now, and if they talk about writing this in A plus BI form, in that case, that would be okay. Technically, if you were doing A plus BI form, if they were really, really specific, which I don't think they should be, you technically would put 13 plus 0i, but I'm not going to ask that. That answer shouldn't even be an option because if the answer is just 13, let's just leave it as 13. You don't have to put the 0i at the end of it. That to me doesn't make a lot of sense, but we're going through those. All right. Now, here's what we're going to do for this one. Here's the big part on this part, and this is where it ties in with the division, is that probably a new word that I don't think y'all have heard before. Conjugates. Now, not in the math setting. You probably heard it in English, right? Conjugates and, participle, all that stuff. Anyway, so conjugates in the math sense, basically here's what we're talking about. When it talks about conjugates, these are expressions where you just change the plus or minus sign in the middle. And for what we're doing with the complex numbers, if we're talking about complex numbers, this is the sign that's in front of the imaginary number. Oh, started off too far there. So when we're talking about complex numbers, when we talk about the conjugates, that's the plus or minus sign that's in front of the I term. Because sometimes later on, I don't know, we'll quite get to it, but if you're in pre-cal, sometimes we'll talk about some things that's there. And sometimes we'll do this with radicals, which still kind of same. But it's always the plus or minus sign that's in the middle. And the big thing on that one is that if we do that, that if we weren't talking about imaginary numbers, if it was x minus 2 and they ask you to find the conjugate of it, then that would just be x plus 2. So if we're talking about conjugates here, if we're talking about with imaginary numbers, if you had 4 plus 5i, then the conjugate of that would then be 4 minus 5i. Because sometimes people will get confused on those because we'll have a number that'd be like negative 3 plus, 7i. And then they'll try to change the sign of the first number. I'm like, no, it doesn't really matter what that first number is. You only just change the sign of what's in the middle or what's in front of the imaginary number part. Okay. And later on, again, I don't know if we'll quite get to this part depending on where we go. that would be the same thing if we're doing radicals. If you had 4 plus the square root of 2, then the conjugate of that would be 4 minus the square root of 2. All right, now here's the big thing with conjugates. Here's where this comes in, and here's what happens with those. If you go back to the one back up here in the beginning, the x minus 2 and the x plus 2, what happens when you multiply two conjugates together? All right, the middle term will always cancel out, right? That when we did 2i plus 3i, or 2 plus 3i and 2 minus 3i, these terms in the middle always cancel each other out. And that's what we're going to do with imaginary numbers, so that if we want to get rid of the imaginary number part of what we're doing, if we will just multiply by the conjugate, we can get rid of the imaginary number for a part of it and get it back into the regular whole number. So then we're working at something on that part. So yeah, so if we're doing, x minus 2 and x plus 2, and you multiply that together, again, the shortcut's going to be that we're going to do, x times x and x times 2. And we've got negative 2 times x and negative 2 times 2. But if you're doing conjugates, these terms in the middle will always just knock each other out. And then you're left with the first term minus and then the second term. So if we were doing these two, if we were doing the parts of the, again, this is where it kind of comes in handy with radicals. If we were doing it with the radicals, if we were doing 4 plus the square root of 2 times 4 minus the square root of 2, you don't have to do, if you're doing the full method, basically here's what it is. You can skip the OI part in the middle, and you can just do the fluff method, basically what it comes down to. Because you're going to do the first times the first, you're going to do 4 times 4 and get 16. And because it's a positive times negative, it's going to be a negative. And you're going to do square root of 2 times square root of 2, which is square root of 4. So then you got 16 minus square root of 4, which is 2. So that's 16 minus 2, so that would be 14. So when you're working with numbers, sometimes, especially if it's two terms, and you want to eliminate something that you don't like in that case. In this case, if it was a radical over here, we're going to work with imaginary numbers because it's working with. You can multiply by the conjugate, and that will help you get rid of that one thing that you don't really like that's in there. And that's kind of the one thing that we'll key on. Now, for conjugates with the complex numbers, you actually get an extra shortcut there. So if we did negative 3 plus 7i times negative 3 minus 7i. Okay, so it's just going to be negative 3 times negative 3. So negative times negative makes that a positive 9. And then minus, and again, we know if we do the next part of it, the O and the I is going to cancel. So then we just need to do the last times the last. Positive times negative is a negative. If you do 7 times 7, that's 49. We do I times I, that's going to be I squared. But anytime we're doing the conjugates, this I squared, we know it's going to be negative 1. So it's 9 minus 49 times negative 1. Well, we do the minus 49 times a negative 1. It'll be just 9 plus 49, so that would make it 58. Okay, and that's the shortcut we're going to use with division, because when we do division, I hate to say it's actually not division, but it's actually not division. It's actually just multiplication because of how we're going to set this thing up and what we're going to work with here. Okay. And it will always be that back up here when we're doing these. This was the first number squared plus the second number squared. This one was the same way. Because of the I squared becoming a negative 1, it's always going to be a plus in the middle when you go back and put these two things together. So it was 3 times 3 for 9, 7 times 7 for 49, and then you're just going to add those two numbers together to get your shortcut there. Okay, so here's what it is with division. Okay, so with division, all right, so there's what division with complex numbers is going to look like. But here's the big thing, and this is probably, I don't know if eventually this may go away a little bit because of computers and how we are, but anyway, they're still making us kind of go through and talk about this one. The big thing with division is you cannot have I in the denominator. All right, and this goes back probably 50 years ago. The reason why on this probably goes back about 50 years ago is that before calculators and computers were strong enough that they could do a lot of stuff, everybody was still doing math by hand. Um, Anybody watch the movie Apollo 13? The one where they were going off to space. This was like the next, supposed to go to the moon. It was the Apollo 11 was first landing on the moon. Apollo 12, Apollo 13 was supposed to go to the moon. They had the oxygen tanks blew up, and so they're scrambling. They're trying to do everything, and it shows them in there where they're recalculating and doing all the stuff, and it shows all the engineers in there, and they're all with paper and pencil working out and doing all the numbers because back then it was really almost it wasn't easy to program stuff in to get the numbers out. That basically it was them doing it by hand to try to get stuff in because it was almost quicker to do it that way. So the push for all this is that if we can get rid of this denominator with the I in it, then it makes the math a little bit easier when we start adding and subtracting and doing stuff. So here's what we're going to do. To eliminate the I variable. So to eliminate I from the variable, or from the denominator, we're just going to multiply the fraction again, we're talking numerator and denominator, so top and bottom, just because it's faster that way. By the conjugate of the denominator. All right, and again, the big thing on that one is that we get a denominator that's just a number, and all right, so here we go. Let's go with the 3 plus 4i and the 2 minus 5i. All right, so for that case, what we're going to do is we're going to take the numerator and the denominator. We're going to take the entire fraction, and we're going to multiply it by the conjugate of the denominator. So instead of 2 minus 5i, we're going to multiply by 2 plus 5i. Same thing on this part. We're going to multiply that. All right, now one small thing that sometimes they don't show you that you probably want to do in this case is when you start getting ready to multiply on these, go ahead and put these things in parentheses, because if not, sometimes people tend to kind of mess this one up. And a lot of times it's not going to show it in parentheses, but just kind of think that you need to put that in parentheses so you can tell that it's this thing times this thing that you're going to have to do the full method. Okay, now the bottom part is, the good thing about the bottom part is there's a shortcut. We don't have to worry about it because we know on the bottom part, if we do this one, it's 2 times 2 for 4. You know, the next two terms are going to cancel out. So when we do the full method, these two are gone. We just need to do the last times the last. So we're going to do 5 times 5 for 25. Okay, now here's the other shortcut you can do with the conjugates. Because we know it's going to be a positive times a negative, it's going to be a negative. But you're also going to have I times I for I squared. So it's going to be negative 25 I squared. But the I squared becomes a negative, so then it's a negative times negative. So this is going to be just a positive. So that's the shortcut you can do with the conjugates, is that if you're multiplying with imaginary numbers, it's always going to be the first number squared plus the second number squared, which in that case means it's going to be just an easy denominator of 29. And that's what we're looking for. What you get in the top, it may be ugly. We don't really care, but the whole thing about doing division with complex numbers is that you got a number that's just a number and not some other stuff that's there. Sometimes y'all see this, and y'all might have done this in Algebra 1, maybe, maybe not. They may have talked about, um, rationalize the denominator. Did you ever see that way back when? Maybe, maybe, maybe not. We'll probably talk about that a little bit later on. But it's basically that same thing that you take a denominator that's kind of complex with some weird stuff in it, and you make it just a number because it's just a lot easier to work with there. Yes. Okay, now top part. It's just going to be full method. There's nothing really you can do with it for a shortcut. So it's 3 times 2 for 6. It's 3 times 5 for 15. We've got the I. Then we've got to do 4i times 2 for 8i. And then 4i times 5, it'd be 20i squared. All right, so the 6 is good. We've got 15 plus 8, that's 23i. And again, at the end with the 20i squared, you're going to take out the I squared and replace it with -1. So we've got 20 times -1, which would basically just make that a -20. And then we can combine the 6 and the -20 to make it -14. That was over 29, and this is over 29. Okay, and here's where sometimes I don't like Math Excel, because sometimes this answer is okay, and they'll let you put in that answer. Other times they'll make you separate this thing out. So it's -14 over 29, and then plus 23i over 29. And I wish they would make it you do it this way, because if this was a 28 right here instead of 29, then you could simplify this fraction, and then it would and that's really what you're trying to do, is that you break it up. So if there's a part of it you can simplify, you try to make it a little bit easier so you can simplify part of it down. So either one of these is okay. I kind of like this one more, because if you could simplify either part of the fraction, then you go ahead and simplify either part of the fraction. All right. Let's do this. Let's give me another one of those. One that looks a little bit different, but it's still the same thing. So let's go with 4 over 7 plus I. All right, so very first thing, again, what we're going to do is we're going to take that 4 and 7 plus I, we're going to multiply it by 7 minus I. And again, a lot of times on these, they're not going to put those terms in parentheses, so I would go ahead and put all those terms in parentheses. Even the 4, if you wanted to, you could. If it's just a number, you really don't have to have that, but if you want to put it there, you could. All right, on the bottom, we're going to do 7 times 7 for 49. All right, again, the shortcut is this is 1i times 1i. If you do 1 times 1, it's still 1. If you do the I times I, that's going to be I squared, which is a -1, so you get a negative times negative. So the shortcut is, again, that's going to wind up making that a +1. Okay. And if you need to kind of work it out a little bit on those, that's fine, because it just takes 2 extra seconds to get you there, because it's 49 times 1 I squared. But again, you're going to take out your I squared and make it -1. So it's 49 minus -1, or 49 plus 1, which eventually gets us 250 for the denominator. Okay, top part. Now, in this case, top part's really not too bad because it's just distributive property. Because you got 4 times 7 for 28. 4 times I is 4i. So that's 28 minus 4i, which, again, if it's distributive property, there's usually not a whole lot. There might be a little bit of simplifying in that part you can do, but that's pretty much about it. Now, this is one of those where if you leave this answer like this, it's going to be wrong, Because if you think about splitting this thing up, and this is what you want to do, if we've got 28 over 50 and 4i over 50, if you do it that way, then you can see, oh yeah, I can simplify because I can divide both of these numbers by 2 to make that 14 over 25. I can divide both of those numbers by 2 and make it 2 over 25. So for that problem, to me, that's a little bit better answer the way it's set up there. Okay. So if you do one of these problems, especially with division ones, if you do a problem and you think you've got the right answer and it says it's in the wrong format, that may be one of those you may just have to click on view an example just to see if they want the answer like this or if they want the answer like that, because sometimes you've got the correct answer, it's just it may not be written in the right form. Where if we're doing a test and you write the answer like this, I'm fine. Math Excel might want the answer like this, where you combine, since you got the same number here, they may want you to then go back and combine those two numbers together. But I'm good leaving it like this for now. It's just Math Excel gets a little bit tricky sometimes. So. Okay, so for division, that's pretty much about it. Now, the only other thing, there's one other one, but I may leave that out there because it's the same thing as this one. It's just one little spin off on it. So hopefully you can work through it and figure it out because I want you to kind of see if you can get it. If not, it's just one problem. You can always come back and ask me about it. Now, here's where this kind of ties in with some other things with the complex numbers. Here's just some random stuff that may throw at you. All right, on the last test, we had to factor something like this, but it was two terms. And we said when we're doing our two terms, we look for a greatest common factor, which this one doesn't have, and we were looking for it's a difference of perfect squares. Well, it's perfect squares, but it's not a difference; it's a sum. So if you get one like this, where it's not a difference of perfect squares, this is one you can actually use I in your answer. So if they ask you to factor some of these problems like this now, you actually can do this, but they should give you a hint of, okay, you're probably going to have to use imaginary numbers. It's still going to be that this is x times x. It's still going to be that this is 9 times 9. But to make it so that we get the imaginary number, because there is no middle term, we want this thing to go away. So basically, this is just the same answer we had of a conjugate in reverse kind of thing. So if we were doing difference of perfect squares, it would have been x plus 9, x minus 9. But because of the plus that's there, it just means we need to go back and put an I there to make it imaginary. Okay, and I waited on that one. We didn't put on the sheet, the factoring sheet we were doing, because everything there was real numbers. That was actual stuff you could, put your fingers on, put your hands on it. You could see an actual number of it. Imaginary numbers, they're imaginary. You can't really put your hands on those and like do it in real life. So the big difference now is if you have a plus when you're factoring on some of these, just realize that in that part of it, you can have the imaginary number here. Because again, if we think about where we're solving these, not that they ask us to solve, but that would be where you could move the 81 over, and then we could square root it, and we would have gotten our imaginary answers. Well, if you got an imaginary answer, you're also going to have an imaginary factor. So just realize they may throw one like that at you just to kind of, and you may look at it and go, well, I don't know, exactly how they got that. Well, that's fine because it's just them working with some imaginary numbers instead. Okay. We did the solving ones like that a little bit earlier. Again, if we were going to solve this one, if we went ahead and finish this out, kind of going through this part of it here. And it would still basically be the spinoff of this one. That'd be plus or minus 9i. Because if we did square root of 81, it would be 9. We said the only thing is if you squared a negative number, just make sure you put an I in the answer, just to let you know it's good there. Okay, and the last couple of little random things that may throw at you, kind of along with the factoring part of it, but it's really more simplifying than it is with anything else. Oh, sorry, I didn't pull that far enough. So here's one would ask you just to simplify. 6 plus the square root of -4 plus 9 plus the square root of -25. Where again, you've got the square, nothing you can do with the 6. You've got the square root of -4. But again, if it's square root of 4, that would just be 2. But because it's a negative, make it 2i. Square root of 25 would be 5. But again, because it's negative, makes it an I term. So go ahead. So where they give you some square root of negative numbers, just go ahead and simplify those numbers down to whatever it is. And then from there, you can just do addition or subtraction. Let's do this. And we're good. So then we've got 6 plus 9 for the real numbers. We've got 2i plus 5i for the imaginary numbers. So that's 15 plus 7i. Okay, so if they give you some parts where they ask you to simplify, again, it could be that it's multiplication, it could be division, it could be subtraction. Just simplify your square root parts that you have. And then after that, you should be able just to either do distributed property or full method or combine like terms or whatever it is that they have to ask you to do.